In this Calculus 3 tutorial, I wanted to show you how to evaluate a line integral. Notice for this line integral, we have ds. This is considered a scalar line integral. Again, you have the ds and you have the function here. And truth to be told, you don't really have that many other ways besides using the parametrization. However, if you do have a different kind of line integral, you have the dx and also the dy. Those right there are called the vector line integral. Well, I do have a video on that already, the 3 main ways that you should know for evaluating a vector line integral. Make sure you guys will watch that as well. But for this, seriously, can't do too much besides using the parametrization. So here's the deal. I'm going to write this down right here for you guys. Here is the x, here is the y, and here is the z. C is equal to t. Okay, so I'm just going to put sine t into the y, and then sine z, well, z is t. So far so good. However, for the ds, you have to know that it's equal to the square root, and this is just like the r-length formula from your Calculus 2 class. So you are going to get 3 squared, and then at the end you will have dt. So what do we do though? You first look at x, and then take the derivative of that with respect to t. So you will get negative sine t. And then you do the same. Look at this and take the derivative of sine t with respect to t, so you get cosine t. And lastly, the derivative of this with respect to t, you just get 1. So again, this part is the ds right here. Now, we are in the t world. All we have to do is go from 0 to 2 pi. That's all. Perhaps I'll put this down in blue as well. And then just pretty much do it. So now have a look. Here we have the integral going from 0 to 2 pi. This is just sine squared t. However, if you look at this, we have sine squared plus cosine squared. That's just equal to 1. And then plus another 1. So in fact, it's just multiplied by square root of 2. And of course, we can put it on the outside if you prefer. Let's go ahead and do that. And then we will have dt right here. Now, to integrate sine squared, remember your trig identities. I will keep the square root of 2 all the way in the front. What we need is the 1/2. And the 1/2 can be put in the front as well. And then I'm going to write that as 1 minus cosine of 2t. So again, perhaps I'll write this down just to make it clear. This is equal to 1/2 times 1 minus cosine of 2t. So I put the 1/2 in the front, and this right here still stays inside of the integral. And now to continue, I'm just going to keep this as how it is. And then integrating 1 in the t world, we get t. Integrating negative cosine, we get still negative, and then sine. 2t inside stays, but divided by 2. So here we have to have the 1/2. And then we go from 0 to 2 pi. Putting 2 pi in here first, we still have that in the front. So we get 2 pi here. Now, when we put 2 pi into here, sine of 4 pi is 0, so that's out, doesn't matter. And then we will have to minus plug in 0, but that's 0. And then sine of 0 is also 0, so that's out. So in fact, this is what we have. And lastly, just get rid of the 2, and we get square root of 2 times pi. So this right here is not bad at all. However, if the functions here, the components function here are slightly